Have you ever noticed the cables all around you? They're everywhere, charging your phone, connecting your computer, streaming your favorite shows. These wires are the hidden veins of our digital world, carrying information that powers our lives. It might seem like magic. Click a button, and a video from across the globe appears instantly. But it's not magic, it's science. Let's uncover the secrets inside these everyday objects. We'll explore how a simple wire can carry movies, games, and messages at lightning speed. The next time you plug something in, think about the incredible journey your information takes. Understanding how cables work reveals the extraordinary science in ordinary things. So, get ready to become a cable explorer and see your charging cord in a whole new light. Let's dive in and unravel the amazing science of cables together. To understand cables, we first need to talk about signals, the way we send information over distances. Imagine trying to talk to a friend across a noisy playground. You might wave or flash a light in a pattern. That's a signal. Cables do the same, but with energy. They send information as patterns of energy. There are two main types: electrical signals in copper wires and light signals in fiber optics. Electrical signals are patterns of electricity, like flipping a light switch on and off rapidly. Fiber optics use pulses of light in glass or plastic strands, like Morse code with a laser pointer. Light signals travel at the speed of light, making fiber optics incredibly fast. When you send data, it's not the actual picture or sound moving through the wire. It's a coded pattern of energy. The cable is just the pathway, guiding the signal from one place to another. Whether it's electricity or light, the signal is the messenger. And the cable is the super-fast highway delivering our digital world in the blink of an eye. That's the magic behind every message you send. Let's see what's inside these cables. Cut open a cable and you'll find it's made of several layers, each with a crucial job. At the center is the conductor, usually copper, which lets electricity flow easily. This is the main path for the signal. Around the conductor is insulation, plastic or rubber, that keeps the electricity contained and keeps you safe. The insulation is like the walls of a tunnel, preventing the signal from escaping. The outer layer is shielding, often a mesh or foil, which blocks outside electrical noise. This shielding protects the signal from interference, like noise-canceling headphones for your data. These three layers, conductor, insulation, and shielding, work together to deliver a clean, safe signal. Without any one of them, cables wouldn't work nearly as well. It's a simple, clever design that powers our digital world. Every part has a purpose, ensuring your information arrives perfectly. Next, let's see how signals actually move through these layers. The science inside is just getting started. How does information actually move through a cable? Think of it like a wave traveling down a rope. You flick one end, and the wave moves along. In a copper wire, electrons don't travel the whole distance. Instead, energy moves as a wave through them. Your device gives a push, creating a chain reaction, a wave of energy that zips through the wire. This wave travels at a significant fraction of the speed of light, about 2/3 as fast. That's why you can video call someone across the world with almost no delay. The electrons barely move, but the energy wave carries your data at incredible speed. So, when you load a web page, it's not a traffic jam of bits. It's a wave of energy delivering your information. It's a silent, invisible dance connecting you to the world. That's the beauty of physics in every cable. Fiber optic cables take speed to a whole new level. They use light, not electricity. Inside is a glass core, thinner than a hair, acting as a light pipe. Light pulses bounce along the core, thanks to total internal reflection, traveling long distances with almost no loss. The cladding around the core acts like a perfect mirror, keeping the light inside. Light in fiber travels nearly as fast as in space, about 2/3 the speed of light. But the real advantage is bandwidth. Fiber is like a 100-lane superhighway, carrying many signals at once using different colors of light. A single fiber can carry more data than a massive copper cable. That's why fiber optics form the backbone of the global internet, sending data across oceans and continents. When you stream a movie, it likely traveled as pulses of light through glass fibers. It's a marvel of physics and engineering, light racing across the world to your screen. Fiber optics make our connected world possible. Let's see how information becomes these signals. How does a computer turn a photo or song into a signal? Through encoding. All digital information is binary, just zeros and ones. Every letter, color, or sound is a unique combination of these two symbols. To send data, computers convert it into a long string of zeros and ones. In electrical cables, a high voltage means 1, low voltage means 0, sent as rapid pulses. In fiber optics, a flash of light is 1, darkness is 0. This happens millions or billions of times per second. The receiving device decodes the pattern back into the original information. The genius is in encoding and decoding these patterns with near-perfect accuracy. That's the secret behind all digital communication. Even the best cables have challenges. Signals weaken over long distances. This is called attenuation. Like shouting across a field, the farther the signal travels, the weaker it gets. Cables can also pick up interference from other electronics, corrupting the data. Shielding helps but can't block everything. Heat increases resistance, causing more signal loss. Poor quality cables or sharp bends can damage the layers inside, making things worse. Sometimes, network congestion, too many users at once, slows things down. Understanding these problems helps engineers design better cables and networks. That's how we keep our connections fast and reliable. Next, let's see why fiber optics are the future. The solution is in the light. Fiber optics solve many problems copper cables face. They're immune to electromagnetic interference. Electrical noise doesn't affect light signals. Signal loss is much lower. Light can travel over 100 kilometers before needing a boost. Fewer repeaters mean simpler, more reliable networks, perfect for undersea cables connecting continents. The biggest advantage is bandwidth. A single fiber can carry many signals at once using different colors of light. This technology, called wavelength division multiplexing, is like a superhighway for data. One fiber can handle all the world's phone calls at once. Fiber optics are essential for our data-hungry future. Streaming, virtual reality, and billions of connected devices. That's why fiber is rapidly replacing copper as the backbone of our networks. The future of communication is fast, bright, and made of glass. Fiber optics are the web that ties our planet together. Next time you charge your phone or stream a movie, think about the journey your information takes. It starts as your thoughts, turned into zeros and ones, then into electrical pulses or flashes of light. The signal races through cables, protected, bouncing, or flowing at nearly the speed of light. At the other end, it's decoded and appears on your screen, perfectly reconstructed. This invisible network is as essential as electricity or water. Cables are more than wires. They're conduits of knowledge, friendship, and entertainment. They connect families, enable remote surgeries, and give students access to the world's knowledge. Our planet is wrapped in these amazing cables, creating a global community. Inside every cable is a story of physics, engineering, and the human drive to connect. And that's a story worth exploring.